Hello everyone, welcome to Coders Camp. We are at 24th day of June LeetCode challenge and the problem we are going to cover in this video is out of boundary paths. So the input given here is a m cross n matrix and three integer values which is maxMove, start row and the start column. The start row and start column represent in which cell we have a ball and the maxMove represent the maximum number of moves we can make to this ball. So overall, we have to return how many ways we can move this ball out of the boundary by making maximum number of moves. So let's understand this problem with an example. So here is our given input. It says the background is 2 cross 2 matrix and we have our ball at the start row start column 0, 0. So we can make overall 2 moves maximum to get this ball out of the boundary. So now let's see in what are the ways we can move the ball out of boundary. As this is in the very top row, top column cell, we can move this ball out of the boundary easily by taking one move. That is towards left, if you move the ball, it is going to take one move. So we are going to add one to our output. And again from the same cell, we can move upwards to move this ball towards outside. So again, we got the second way to move the ball outside of the ground. So as per the problem statement, you can move your ball four directionally to any of the cell. So we have chosen the option to move it towards left and right and we added that to our output. So other two options are moving to the next adjacent cell as well as the down cell. So that will not take the ball outside of the ground, but we can make or we can explore from that path if we can make any moves to make it out of the ground. So let's move it towards down, and from here your total number of moves is 2. So you have made one move, you have one more move left. So we are going to check whether by making one more move we can take this ball out of the ground. Yes, we can do that by moving it downwards or moving it towards left again from here. So overall it is going to take two more solutions to move the ball out of the ground by making two moves. So again, the option we explored is moving the ball towards down cell from 0, 0. So what if we move the ball towards 0, 1? So by moving to 0, 1, out of your max 2 moves, you have used one move. So you can make one more move to check whether we can make it outside. Yes, we can make this ball to outside of the ground by moving it upwards or towards right from the cell 0, 1. In total, we took two moves. So this is going to be added to our solution as two more solutions. So from 0, 1, you can move it to 1, 1, but moving that from 0, 0 to 0, 1 and to 1, 1 has completed the overall moves of 2. So you cannot further make any more moves to make it out of the ground. So in total, we have got 6 different ways to make it out of the ground. So clearly, we have to try out all possible options by moving ball in all possible ways, and by making the maximum number of moves, you have to bring the ball outside. So always we are going to try a DP solution or recursive solution if we have to explore all type of paths to come up with a solution. So we are here going to see a recursive solution where we are going to have a method which is going to explore all possible ways in all four directions to move the ball, and for every move it is gonna make the movement -1. For example, from 0, 0, if we are trying to move to 0, 1 at the next step, then starting with two moves, it is gonna call the same function recursively by one move because we have already made one move and we have left with only one move here. So by this, we are going to explore all possible paths and finally add the number of steps we go till we reach outside of the cells. So hope you're understanding this solution. We are going to have this recursive solution plus memoization. I'll explain memoization while coding it. So before getting into code, this is going to work in big O of 4 power n time complexity, where n is the maximum number of moves we can make to the ball. So let's go to the code now. So yes, first let us write our recursive method, then move on to our main method. So this method is going to take parameters of m, n and R and C are the row and columns of the cell where we are moving our ball to, and N is the total number of moves. So this says if we reached any of the edge cells in the given grid, then in that case we can move it outside by making one move. In that case, we can add 1 to our solution that we have found one way to move our ball outside. So I'm going to calculate my result in all possible 4 directions. I'm going to call the same method by having m comma n, and we can move the ball by one step in all 4 directions. Then the direction is going to be either +1 or -1 column, or +1 or -1 row. So finally return the result. So yes, this is it. From our main method, we are going to call this function find. So yes, this is it. But if you run the solution exactly like this, it is definitely going to time limit exceed, as it is going to explore all the paths. The function call is going to be stack overflow for definite reasons. So in order to reduce the number of function calls, we are going to implement memoization. So in my main method, I'm going to declare a 3-dimensional DP array where the columns and rows represent the index of the ball we are moving to and the total number of moves we are left with. So first we are going to fill -1 completely. So this is the base condition that if there are no moves available, that is only 0 moves, then in that case we cannot move it out of the boundary. So the solution is going to be 0. That is why we are assigning for n at the position number of moves 0, then the solution is also 0. So here we are going to save our result in our DP, and we have to return it in modulo of 7. So as we have stored the values in DP, we are checking if DP is not equal to -1. In that case, we have computed something and stored it. So we are going to return that value. So yes, this is it. Let's run and try.